This is part 3 of section 11.1 on vectors in the plane, 2 dimensions, and various terminology and things, types of problems associated with them. And we're about to launch into example 3 here, where we have a few different things to do and have to do some plotting here. So let's see. The initial and terminal points of a vector v are given. The initial point is 2, 0, and the terminal point is 6, 4. Let's sketch that. That's part A. 2, 0 here, initial point, and 6, 4. So that's the directed line segment. Write the vector in component form. So I feel like I can't resist getting into doing part D straight away in connection with part B because they're totally related, right? The parts B and D really totally go together, and as I said, I'm gonna not be able to resist essentially doing D first. D is sketch the vector with its initial point at the origin. So that would be the new initial point, and the terminal point would have to move over to here. So this would be the answer to part D. Okay. And it's also totally related to the component form. Okay. Now we didn't need to sketch first before we did component form because we did this right here. Example 2, how do you find the component form? That's what we did right here. No sketching involved. But this one's so easy to see, and it's just nice to see the connection between what we did in that previous example and what's going on here. You see, this new terminal point is 4, 0. And so that's the component form. But also how we did it in the last example applies and makes sense. Like, oh, shoot, I made a mistake, sorry. Neat. Don't know where I came up with 0 for that point. 4, 4 is the new terminal point. So the component form is that. And that makes sense with what we did in the previous problem to come up with component form by taking the initial point here. And in this case, we'd have to subtract 2 from the x value. Great, because see what happened? 6 became 4 when we thought about it more graphically. Now, this is the interesting part of this little example. The initial point y value was 0 already. So we don't do anything to the y value. And that's the case here. The y value stays the same. This is whether we do it more the process numbers wise or graph wise. We get the 4, 4 for the component form. Now about part C, it's talking about writing the vector as a linear combination of the standard unit vectors I and j. So what does that mean and how do you do it? Pretty easy as you'll see, but you have to understand the terminology. And it has to do with what I and j were defined to be, which in component form were those 2 vectors. Now this business about linear combination, what exactly does that mean? I will show you. So we're dealing with this vector, it's called v. And we know now its component form is 4, 4. Once you see this once, like going from component form to linear combination of I and j, you won't need to do really any steps. It's kind of going to be obvious to you, but I want to show you all the steps in all exact detail. And this is equal to, or we can write this as the sum of the component form 4, 0 plus 0, 4. Because when vectors are in component form, we add the coordinates. 4 plus, so we'd add x values 4 plus 0 to give us 4, and y values similarly. I kind of wish this example was not 4, 4, but it's too late now, but maybe like 4, 7 or something like that, in which case it would be 4, 0 plus 0, 7. So the y value is added, 0 plus y value 4 gives us that y value. So we can do that. And then the next thing we can do, kind of just writing it out wise, looks like a kind of like a factoring thing or a distributing thing, but it's really a scalar, what's called a scalar multiple. The number 4, that's just a number, times the vector 1 comma 0 is equal to 4 comma 0. Because what we do when we multiply a scalar, which is the word we use for a number in this topic, a scalar times a vector in component form is multiply that scalar, that number 4 in this case, times each of the coordinates. And so 4 times vector 1, 0 is going to be the number 4, here, times the number 1 there is this 4. And the number 4 here times this 0 is that 0. Okay? Now I'm not done with that equals yet because I only have accounted for the first vector, so I need that plus another 4 in this case times 0 comma 1. So these two vectors we've gotten to now in this form of this vector v, which is where this whole thing started, that's I and j. So we can write this as 4 times vector I plus 4 times vector j. And that's the answer to part C, right? The vector is a linear combination of the standard unit vectors I and j. Let me pause here for a moment because I think I left off the word standard when I was talking about I and j. These are the standard unit normal vectors, I and j. The point is that unit normal vectors could be any two vectors, each of length 1 with a right angle between them, but could be anywhere. But the standard ones are these two. Now, so I want to say on this part C about this problem, just to maybe do another quick one. Like we're done with this problem, example 3 totally, but just this writing as a linear combination of standard unit vectors I and j. Here's another component. This is not, again, part of example 3 as it's stated, but let's just take this component form of a different vector, negative 3 comma 7 in component form. Okay, and let's call that u just for another vector. And then u in terms of what's called a linear combination of I and j would be negative 3i plus 7j. And so it's always going to be the case that if you have a component form of a comma b, then the linear combination form in terms of I and j will always be a times vector I plus b times vector j. And it really does always work like that. Sometimes in math you got to be wary of things like that. You say, does it just always work like that? And sometimes it's like, well, no, it's because the numbers were like 0 and 1, so they're special. But in this case, it's straightforward. If you have the component form of the vector, you essentially have the linear combination of I and j form as well. Okay, I'll stop this one here and continue on in the next part.